Hey, welcome back. Y'all had a nice spring break. Maybe not long enough, but it's what we get. Um, so first of all, if you saw my announcement, I've looked over the material. Uh, Basically, we'll look at 8.3. What 8.1, 2, and 3 was kind of going over sort of the same thing multiple times from different perspectives. So I'm going to focus on the applications and deal with the vocabulary that we could call it a relative frequency, or we could call it a probability, or we could call it a percentage. They're all really the same thing. So we're going to focus on just doing the math. When we get to 8.4, there's only two questions, and they're very similar. Basically, there's two questions in the review and then 6 questions in the homework, and they're all about grabbing marbles out of a bag and what's the probability of getting this color versus that color. And so it's a pretty short application or presentation. We'll look at a couple examples, and you'll see it uses the calculator a lot using combinations that we've talked about before. So all the stuff we went over the week before spring break in chapter 7 is really just being applied again. So hopefully, well, whether you've gone through them or not, it's a good time. If you haven't, go back through that chapter 7 stuff, because that's basically what this stuff is going to be, applications of it. If you've gone through the 7, you'll see the applications coming out fairly clearly. You say, oh, that's just like those other problems we were doing, but now we're going to call it a probability and go forward. With that in mind, we can move up the exam or the review date by a date. So we got the 2 days. I have to be out of town on Friday for family matters. I'm flying to San Francisco actually Wednesday after class. So I thought I could get someone to substitute. We'd still have the test on Friday. However, I know department policy is that tests get cut off right at the time. I personally don't believe in that. I don't want to cut you off, but I know whoever I got to do the substitute would say, okay, it starts here, 8:50, it's done, and if you're not done, they're going to collect them. So I like to have the control, and control the environment on tests. So if we move it up to Wednesday, I can do that. I can have sort of a soft landing. I'll say, hey, class is over. You should be finishing up. But like last time, I won't cut anyone off. I'll let you, because we've got office hours afterwards. Does that sound acceptable? Okay. And in a way, it's probably better because we can start the review, and then you've got a whole weekend to work on things, and then we could do a finish up, and then it's all fresh, and let's just do it. And then Friday we can recover or whatever we need to do. I'll be kind of busy myself, and I'll get work on those, and then we can start into the chapter or the exam 3 stuff, which sort of continues on. But remember, once we finish this stuff with exam 2, we're done with all of it. And the new stuff, we may apply some of the concepts, but we won't be tested directly on any of these things in exam 3. Okay, so let's plan for that. If you have any issues or any problems with the exam being on Wednesday instead of Friday, contact me, talk to me. We'll work it out. I'm thinking most people it's actually preferable, because few people had contacted me that Friday tests were actually a problem for them because they're used to Monday and Wednesday. So I'm thinking it'll be a sort of a winning situation for all of us. But yeah, if you have any issues, just contact me. We'll come up with some options. All right, let's then see what I want. I go back. And what I did was kind of like, there was these long PowerPoints, and I had to go, this stuff is just saying the same thing over here as in 8.1 and 8. So I ended up deleting most of it. It was like 90 slides, and I've got it down to just a few. I'm also embedding the slide decks, because I think this will do a little better. And I was able to embed a calculator, the NumWorks, which you can use for free. I'll demonstrate a little bit. I still have the TI 84 calculator, because I know a lot of you are using them, so I'll show you how to use those. But I'll be using both versions. And if you want to, it's basically in the module here. You could play with the other calculator, and I'll just see how this works, get a little practice with basically having the Google Slides embedded. There's also a link if you want to go directly to the Google Slides, but you can watch them from here and go through theirs. So, main thing is, what is probability? Someone, if your younger brother or sister who's maybe 10 said, "What's probability?" What would you tell them? Simple. What would be your, what's probability? Anyone? Perfect. How likely something's going to happen, the chance something's going to happen, maybe. It's got that word maybe, right? Maybe it'll happen, maybe it won't. So excellent. And so the concept is, in probability, something is going to happen. Even if it's nothing, that's something, right? So you could say it's either going to rain or not rain. So you say not rain is nothing, but no, it's something. So there's always something is going to happen, or it's going to say, but there's that. So what we do is, that's the holistic thing. There's 100%. So we start off with thinking that at one end, let's go with red. There is a, what's going on? Shoot. This happened to me yesterday too. Let's see. Well, now it's locking up. It'll work. Try this. This pen's a little fatter, but we'll see. There's a 100% chance something's going to happen. There are some items that might not happen, right? So let's think of, if I'm going to roll a dice, it's got numbers, generally a standardized 1 through 6, right? Dots on it. So is it possible to roll a 7 with a single die? It's not. So that would have a probability of 0. So 0 to 100%. So that's the idea, is that there's going to be some individual things that could happen, but that in totality, there's something's going to happen. So if we add them all together, we get 100. So that's just a simple thing. Could we have more than 100% chance of something happening? No, because then that means we didn't count something. 100% is everything. And if there was some extra out there, well, we just forgot to count it. So the idea is, if we count everything, that's 100%. So that gives us what we call a probability distribution. Again, and what you'll see in math, we'll use some special words, vocabulary. Think about up in Alaska, there's certain tribes that live up there in the north, and they live in the snow, the Inuit. And I've heard they have like 20 or 30 words for snow, of different types of snow, because that's where they live. And that's, they need all those words for the different type of snow. When you're a mathematician, you need all these other definitions for math things. However, most of us who are not mathematicians, and I'm not a mathematician, I'm a math educator, we just do the stuff without necessarily having all these specialized vocabularies. But you'll see it in the homework. So what is a distribution? It's a listing of all the events and what their likelihood of happening is. Some things are more likely than others sometimes. And so the thing is though, each little thing that's going to happen has to have a probability, a likelihood of somewhere between 0 to 100%, right? Because you can't have more than 100%. If it's 0%, we say it's impossible, so you can't have negative chances of happening. So it's just 0 to 1. So each individual event, we say, what is it? It's, it could rain, it could be cold, it could be hot, it could, there's all the, whatever. We list everything, and each has a probability of happening. And so each one has to be between 0 and 1. And then the other part, these are really the only two rules. If we add all the probabilities together, we have to get 100%. Otherwise, we didn't count something. So that's the basics of probability theory. And we're going to work with that. But then we'll look at some specific examples of how this all fits and what we have to do, because this really is probability is about counting how many ways something can happen. That's why we did the counting. So to get the probability of some event, and we call it E for an event something happening, right? We use some notation. We use this P of E, so the probability of an event. What we do is we add up all the outcomes, all the ways that we could get that event, because sometimes there's more than one way. We're going to look at like rolling 2 die. There's more than one way to get a 6. You can get a 5 and a 1, a 3 and a 4. No, 3 and a 4 is 7. A 3 and a 3, right? So there's more than one way to get a 6. So if that's our event, we count all the different ways we can do that. And those are called outcomes, right? A 5 and a 1 is a particular outcome. And then we do anything that can't happen, like if we got 2 dice, probability of rolling a 13 is 0. Probability of rolling a 1 is also 0. Okay, so those would have 0 events or 0 probabilities. And then we'll just go with flipping a coin. Okay, so if we flip a coin, we get either a heads or a tails. We could assign the probability, if it's a fair coin, that there's a 50-50 chance on either side. Okay, we're going to look at sometimes we could have an unfair coin. Maybe one side's heavier, so if gravity will pull it down or something. But if they're equally likely, there's 2 events, it'd be 50-50. Okay, there's 3 events, then it's 1/3 for each event if they're equally likely. Okay, so we call that for an item that's like rolling a dice or something, that is a fair dice. If we weight one end, it could be unfair, and the probabilities change. Okay, and if we look at this, again, we can either look at probabilities as decimals, or we could look at them as percentages. So 0.5 is the same thing as 50%. They also call a percentage a relative frequency, how often something occurs. So we'll be using that sort of same thing. But again, in the end, this is the theory that there's 50-50 chance. How are we doing so far? Nothing too new? Okay. So here's an example. Now this is just gone off. This is not necessarily a dice or anything, but there's something we can get the numbers 1 through 6, and they're giving us what's called a sample space, that the outcome of getting a 1 has a 30% chance, 2 is a 30% chance, getting a 3 is a 0% chance. So it's impossible to get a 3. Maybe somebody ate it or something, who knows. 4 has a 10% chance, 5 is and so forth. And so if you want the probability of getting I guess this is a 1 or a 6, that would be 0.3 plus 0.1, right, from here and here. You would just add them together, getting a 1 or a 6, add them together, we'll get 40% chance. So it's just, most of this is, we have probability 2 things going, we just add them. Probably a 2 and a 3, well, 2 is 30%, 3 is 0, 30% plus 0% is still 30%. Okay, so some examples here, and then, yeah, event 3 is impossible because it has a 0% chance. But notice if you add all those together, 0.3, 0.3, 0.3 and 0.1, you get 1 or 100%. And I'll just write sum equals 1 or 100%. Okay. And so the idea with probability is that those are theoretical probabilities, but if we flip a coin, say flip a coin 10 times, is it possible that they're all heads? It's possible because probability is a likelihood. It's not a guarantee, it's a chance. And then, yeah, we have a chance to get 10 heads in a row. So what happens though is the way probability is, while it's a thing, why we can do these theories, is that if we do it a lot of times, like this one, what we do is we get closer and closer. Here's a relative frequency of getting ahead. As we flip the coin, here about, let's see, what is this? This is maybe like 75 times. We're almost at 60% heads. You say, wait, the coin's supposed to be 50-50. Well, it just so happens that with 75 times, we had 6 heads out for every 10 flips. But the more times we do it, what we start to see happening is that probability does work over time. We get closer and closer to this 50% level. 50% heads, 50%, the more times we do it. Okay, that's why so there's 2 things going on. We've got a probability theory of what we think will happen, what's most likely to happen, and then we have the actual thing that happens. And basically, on any given day, anything can happen. So our team might come in with a 90% chance of winning, but they could still lose, right, on any given day, because whatever happens. Okay, so I've got a little applet. You're welcome. And the reason I have these embedded, if you go into the module, it's a little more accessible. You don't have to actually pull it up, the thing. So how about if we had an unfair coin where there was only a 20% chance of getting a heads, an 80% chance of getting a tails? What would you think would happen? What would you expect maybe after, if we flipped it 10 times, what does that say? How many heads would we get out of 10 flips? 20% of 10, 2 times, right? So that's sort of what we expect to happen, but it could be different. So we're going to click here. Oh, I think I have to turn that off. And if you come to here, there's a couple other different types of simulations. Played with this a little bit. What we're going to do is we'll go with 8 coins because that's as many as it will give me. And I'll flip it once, so it's going to flip 10 coins, or not 10, it's going to flip 8 coins one time. Probability of, well, let's leave it at 50-50, what we usually get. So we flip 8 coins, how many heads do we expect to get? 50% of 8, 4. So I'll do that, and we actually got 5 heads with just one flip. Flipped it again, I got 5 again, and you can kind of see here. So you can play with this. Wow, I keep getting 5. Oh, there, I only got 2 heads. So we see what happens. I'm going to do 10 flips at a time, so flipping 8 coins 10 times. And what we start to see, the more I do it, I'm getting closer to either having 4 or 5 heads, which is, right about that 50%, right? And if you click this little play thing, it'll just kind of keep flipping it, and you see, hey, you can do thousands of it, sitting here, watch it. And we get closer to being somewhere between 4 and 5 as we flip more and more coins. Okay, so just kind of watch that for a while. Now let's change it. Let's change our probability of getting a heads to 20%, like I said. Still got our 8 coins. One flip, what should we get? Oh, 2. 20% of 8's about, I think, 1.6 if you do the math on it. So somewhere between 1 or 2 heads is all we're really expecting now. And again, we keep trying it. Oh, we got 4, we got 3, we got 1. So there's this randomness part of probability. And again, we can go for 10 flips, and we see that, right around 1 to 2, 1.6 is actually the average. That's what we're getting the most of. But we also can get, even at a 20% chance of getting a head versus a tails, we still can get down the road. We haven't seen any 7 heads or 8 heads because of that probability, but that's just sort of how it works. Okay, so probability is not a guarantee, it's an estimate. Okay, so the calculations we're going to do are estimates of what's most likely to happen, but it's not a guarantee. It's really just a maybe. Okay, so you can play with that if you'd like. So let's go ahead. Now we're ready. That's all the theory stuff behind us, 20 minutes of theory stuff. Let's get into working some problems. Let's try one like the exam review. So what I did is I went to the exam review, copied it over, changed the numbers a bit so you could go back to the exam review and sort of just follow this as a template, sort of, but you still have that chance to work it on your own. Okay, let's see if I can get this thing to work. No, it's... There we go. Okay, so consider the experiment, and when we do these flip, that was an experiment as far as probability. You just flip, math scientists, all they do is flip coins, roll dice, pull marbles out of bags. That's our experimenting. A coin is flipped 4 times, so that's the experiment. Let A represent the event that heads comes up at most 2 in the 4 flips. Find the probability of that event. Okay, so this is how we're going to have to go about doing it. Now, when they say fair coin, that's a 50-50. Okay, 50% chance. Otherwise, they would have to give us the probability. So if we flip the coin 4 times, what are all the things that could happen? We could get a heads, 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 right? And what we have to do in the sample space is we have to count all the possible things that could happen. Now, as we get going a little bit later, we'll see. We'll use combinations and such. We could get, see, a heads, 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 tails. That's way 4 heads, 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 tails. We could get a heads, heads, tails, heads. We could get a heads, tails, heads, heads. And we could get a tails, heads, heads, heads. So there's all the ways we could get 1 tails. We'll come back on. So far we're up to 1, 2, 3, 4, 5 ways. And then how can we get, so that's 3 heads, 1 tails. We could count how many different ways. And again, since we're flipping it 4 times, each one of those is a different event, right? Or well, we haven't defined them as an event. We're going to define the event as having at most 2 heads. But these are each a different type of outcome, right? Different kind of outcome. So then we go through, let's see, I could have a heads, heads, tails, tails. I could have a heads, tails, heads, tails. I could have a heads, tails, tails, head. And I could have a tails, head, tails, head, and a tails, tails, head, head. Now, you'll be thankful that the one that you're asked to do in the review has only 3 times. So I took the harder one. So 3 times is going to be easier to count because you've only got 3 flips and you've got to kind of go through all this. But it'll be helpful. So that's 2 tails, 2 heads. Did I get all the different ways? Kind of watch me to see if I missed anything that you can think of. I think I got all the different arrangements. And then we could have 3 1 heads and 3 tails. And again, that's going to be kind of mirror this one. So heads, tails, 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 a head, a tails, a tail, tails, a tails, a head, and a tails. So I'm just moving the head along. A tails, a tails, a tails, and a head. Oops, a head. And then the last string, I could get all tails. So I should have accounted for all the actually permutations, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I feel like I probably missed something. 2 things for each. 2 times 2 times 2 times 2. Should get 16. I'm missing which one? Tails, head, head, tails. Tails, where should that? Oh yeah, here. So we could have had a tails, head, head, tails. So if we use that stuff we previously did in the counting, I knew I got 2 choices each. So 2 times 2 times 2. I should have had 16. Yes. Well, it would be 2 to the 4th. Yeah, yeah. So we could have done that. But I also wanted to show the sample space because now I've got to count how many of those. So there's 16 total. And how many of these have at most 2 heads? At most 2 heads. That means 2 heads or less, right? So no heads. Okay, there's 1 here. There's 1 head here, 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 and here. These have exactly 2 heads. And this one that I forgot to count up here. And this one has 2 heads, and this one has 2 heads. These ones all have 3 heads. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that had 2 heads or less, at most 2 heads. Does that make sense? And so I can leave this as, this is a one way of writing probability, and sometimes they're going to ask for you to leave it as a fraction, 11/16. Other times we'll turn it into a decimal. So that's 0.6875. Or we can write it as a percentage, 68.75. Multiply it by 100%. I personally like percentages because I can think a little easier in percentages. I can compare that to 100 than I do the fraction. Okay, so that's one type of activity that you will be asked to do in the homework as well. And some of the homework they're going to ask you about setting up the sample space, or what would be the sample space. So I wanted to go through this as kind of tying in a couple different problems as well. Yes, you could also do this a little more analytically, 2 to the 4th or 16, and then you could have, well, how many would have just 2 or more? You could have, there's some ways we could have used our counting techniques, but the ones we'll give you will be small enough that you can actually write them out. Okay. So taking this a little further, another type of example will, like I said, we do rolling dice. If we have a single die that's fair, 6 different things could happen. Any of them are equally likely, so that would be 1/6 for each of the numbers 1 through 6, right? So again, there's this important thing is equally likely. Not everything is equally likely. So just don't think, well, there's 3 things, so that means a third. It is if they're equally likely. Sometimes there's a larger probability for one thing happening than another. Okay. If we roll a pair of distinguishable dice, this first time I've seen them use that word. We get all these different possibilities where you can get a 1 and 1, a 2 and a 1, and a 2 and a 1 is different than getting a 1 and a 2. And from our previous lecture, we had this, so then you could really see a 2 and a 1, a green 2 and a pink 1 is different than a pink 1 and a green 2. So physically they're different, so we have to count all of those. So when we're rolling 2 dice, it's not, how many would we think? Maybe, so there's 6, we might think there's only 12, but there's actually 36 different things that could happen. Okay, 36 different physical outcomes. Even if they're not distinguishable, they're 2 separate dice. Even if they were the same color, it's the same concept. There's a first dice and a second dice. So everything for any particular one event is 1 out of 36. Now, when we start thinking of outcomes with dice, we think about the sum of the 2. So then we start counting how many different ways can we make a 3. That's right here. There's 2 ways to make a 3. So that's 2 out of 36, which does reduce down to what? 1 out of 15, 18, 1/18 or something. So you can do that. So that would be the probability of getting a 3, where we think of 3 as being the sum of the die. Okay. But remember, there's 2 different ways for that to happen. That's why if I'm going to use a fraction, I prefer not to have the reduced form, because I can see 2 out of 36. 1 out of 18, I kind of lost some of the counting. Or I go to percentages, because then it's all good. Okay. Take E to be the event. The sum of the numbers that face up is 5. So how many different ways can we make a 5? Well, they've got the listing here: a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So there are 4 different ways to make a 5. And there are 36 ways, 36 different potential outcomes, physical outcomes, right? So this is getting us our probability. This is the whole thing. It's the number of favorable outcomes. I shortened to that good things, or whatever we're looking for, whatever we think is a good thing. Good things divided by total things. Just think in that terms. Good things divided by total things. If you don't like the, or maybe bad things, whatever it is, whatever we're looking for, things divided by total things, whatever in that set. And that's all a probability is, okay? And again, we deal with theoretical, what sort of we think is going to happen based upon the setup. And then there's also another type of probability of what actually happens. And we saw that in the short run, anything can happen. And so we run these experiments and actually roll those dice, and what we thought was fair might not be a fair set of dice. That's how they do it. Okay, so yeah, here's the probability. You could think of it 136, 136. So each of those outcomes has a 1 out of 36 chance. They're all basically the same thing, or they're both giving us a result of 5. And so that's 4 out of 36, which is 1/9. Okay, reduces down. Again, I kind of like thinking in terms of the fraction like this, or turning it to a percentage. 1/9 is, I think, about 10% or 11%. Is that right? 1 divided by 9. Yeah, 0.111, about a little over 11%. So, you do any dice games, 11% chance of rolling a 5. So here's one on the exam review. Considered experiment with 2 fair distinguishable dice are rolled. Let B represent the event that the sum of the 2 numbers is 8. Fine. So this is basically the same thing. We just got to figure out how many 8s there are. And I'm going to pull up this, which, again, you could reconstruct this on an exam or something, because you got to try to remember. But I'm also going to point out that there's sort of this thing that happens. So here's the 7s, and let me change color. Let's go with blue. So if we go along this diagonal, there are 1, 2, 3, 4, 5, 6 ways to make a 7. If we come down here to make a 6, there's going to be 5 ways. To make a 5, there are 4 ways, just like we just counted. It's these. To make a 4, there are 3 ways. And to make a 3, there are 2 ways. To make a 2, there is 1 way. Okay? So you can see, starting with 7, it's just sort of 1 less. So you can think, how many ways to write a 7? Well, there's only 6, 1 less. 6, there's 1 less than that. And then it mirrors itself as we go up. Okay? Please come back on. I don't know why it's... Thank you. Just be polite. And then when we go up, the ways of rolling an 8, right, are here, which are 1 less than the 7, so that's going to be 5. Well, let's do it down here. 5, 4, 3, 2, 1. So there is a symmetry that occurs. And so if you just kind of do this a few times, and then you won't have to actually reconstruct it all the time. But so how many 8s are there? There are, we're going up, so there's actually, just think 7, rolling a 7, there's 6 possible ways to do that. So if we go to 8, I'm going to have 1 less. It's going to be 5 ways. So the probability of getting an 8 is the 5 divided by 36. And again, we could turn that into a percentage. So about 13.8%. And also, if they ask for a reduced fraction, we can see if it's going to get to be a reduced fraction. We take 5 divided by 36, not 13. And then if you go to your math key and fraction, if it reduces, it will reduce it for you. So that's just, we don't have to worry. Sometimes the hardest thing is remembering how to work with fractions, or remembering the tools that you have to work with fractions. I know this is reduced now, okay? But if it wasn't reduced, it would reduce it for me. So far, so good. We only got, we're pretty close. So what is probability? Again, this is just sort of a visualizing. We have our sample space. We have things that can happen. The green is sort of one event. Whatever it is coming out green. The pink is everything of it not happening. And so the probability is 1, 2, 3, 4, 5, 6. There are 6 in the green region. And there are 1, 2, 3, 4, so a total of 10. So it's a 60% chance that whatever this is, this event in the green region, happens, right? It's just counting. So it's observation. We use this all the time in sports. Batting averages are just how many times they get up to bat and how many times do they get a hit. Divide that, and that's your batting average. It's a percentage. And that becomes a probability. So each time that person comes up, you think, well, they're batting 345. That's means 34.5% of the times they get a hit. So they've got a 1 in 3 chance, but they might be having a bad day. They might be having a good day. It could be different. Okay. But notice some of the things that are going to happen. What's the probability? Remember, we counted the logic of what's the probability of E not happening. The 60% chance of happening is going to be 40%. Just subtract it from 100 because there's got to be 100%, right? So it'll either happen or it won't. It's always going to be subtract from 100, 40%. Okay, so those are, it's kind of simple, but it's also easy to forget some of these things if you haven't been working with them all that much. So here's one. Again, you could probably look this up. I think the review question asks a very similar things. Flip the coin 3 times. What's the probability of getting, well, in this case, exactly 2 heads? And not 2 heads are no more than 2 heads, exactly 2 heads. So we have to come through this and count all the time we have exactly 2 heads. There's 1, 2, 3, 3. So 3 out of 8, and that's 3/8. And we could turn that to a percentage. I think an eighth is 0.125, so that's 3/8 is 0.385, 375. In mortgage loans, everything's done in eighths. So I used to process mortgage loans 30 years ago, and I was really good with eighths before, but it's been a while. So 3.375, okay, which is a 37.5%. Okay. Here's an example, and this is, again, in the homework, they have something fairly similar. Again, it's just counting what's the total and how many things can happen. So total of 1.35 million plug-in electric cars had been sold in the United States from 2008 to 2020. And then it gives us a breakdown how many were Teslas, Chevrolets, Volts, Nissan Leafs, and so forth. The question we're going to get asked, so that's a total of 1,350,000. Actually, I didn't see it up here, but so what is the probability that a randomly selected plug-in electric car sold in the United States was either a Tesla or a Toyota Prius? So again, we're just going by what's been observed. So we will add the Teslas together with the Priuses. Where's the Prius? Toyota, oh, something got cut off. 110,000. So it's just going to be 740. I'm just going to put K plus 110K divided by 1,350K. So 7, so that's 850,000 over 1,300,000. And again, a lot of times they're going to want this as a reduced fraction. You could see we could obviously cut off the zeros, but we can also put that in here. Got that right. And then just remember to come here with math, turn it back into a fraction, and we get it's a reduced fraction of 17/27. Took me probably 5 minutes to get to that if I did it by hand, but that's the answer that WebAssign's going to want. Okay, but again, it's just counting, and in this case, we added the 2 cars together, getting this or that, add them together, divided by the total. Good things divided by total. Make sense so far? Cool thing is we don't get too much complication. We don't do any conditional probability, which some of you may have done before. Oh, here's a good one. Is not a Chevrolet Volt. Okay, to calculate that's not a Chevrolet Volt, and I want to show you that there's a fast way to do this and there's a slow way. And I usually think, okay, not a Chevrolet Volt, so let's add all the ones that are not Chevrolet Volts, and then divide by that, and then we get it. Well, that's actually the longer way to do it. It's not that longer. But what we could calculate is what's the probability of getting a Chevrolet Volt, and then just subtract that from 1, right, or 100%. And again, but when you're taking a test, sometimes that can be the difference because it saves you time. And I was studying graduate level probability, and some of these questions got real complicated. So it was the difference between a 10 minutes to calculate it or 2 minutes. And how many brain cells did I use up trying to calculate it the hard way? So we'll just say, okay, Chevrolet Volt. Let's see, where's the Volt? 100. Oh, there it is. Yeah, it's kind of, okay, 160. So we just do 160 divided by the 1,350 0, 0, 0, 0, but we're going to subtract that from 1 because that's not what we want. So the not part, 1 subtract that will give us what we want. Okay, and you can just put that all into the calculator. I'm going to put a parenthesis so it'll come out at the end. 1 minus 160, 1, 2, 3, divided by 13, 5, 0, 1, 2, 3. And remember the fraction. $119 out of 135. I guess I didn't do that one. That number doesn't look familiar, but that's what it should be, right? Okay. So if it's asking as a fraction, we do this. You could also do it as a percentage. Again, percentages have a lot more meaning to me. This I can kind of compare. Well, that's more likely than not, right? But percentages, I don't know what that's probably like closer 80 or 90%. So that's good. Questions so far? Okay, we got about 5 minutes left. Let's see where we're at. This is kind of we're going to have actually a lot of time because I've only got like 2 examples to look at on the marbles one, and it's going to come right off of this. So why don't we do this instead of either rushing through? Let's go ahead and stop here. We'll do this. We'll pick, this will give us maybe the 10 minutes, 10 to 15 minutes on Wednesday. We'll pick up this part, be another 10 to 15 minutes on doing marble probabilities, and then we'll be done. We'll still be done early Wednesday, and we'll start into some of the review and going over, and I'm going to start making some videos on the technology. So I'll make one sort of, these are all the technology things we need to be able to do. And I'll do it for both types of calculators that we've got. So does anyone have been using a Casio calculator? Okay, I have a Casio, so I'll make some videos on those too. So just to help us all out. So just kind of the bare bones, know how to do these things and we'll be good. All right, thank you. And we still have our office hours.